Hello everyone. So today we're going to tackle about a portion of the lesson of radical expressions. We're going to make your life easy using some techniques on how to answer some radical expressions, hopefully all of them, as you are a grade 8 student. So imagine this, ponder this answer, square root of 81. But for the basis, before we answer this, we'll have to tackle square roots. First would be 1 raised to 2, or 1 to the 1 squared would be 1, since 1 times 1 is equal to 1. 2 squared, the answer there would be 4, since 2 times 2 is equal to 4. Square root of 3 would be 9, since 3 times 3 is equal to 9. 4 raised to 2, or 4 squared, would be 16. 5 squared would be 25. 6 squared would be 36. 7 squared would be 49. 8 squared would be 64. So now that we have the first to the 8th, let's check some common sense with this, some logic you might want to think. The interval between 4 and 1, the first and the second, would be 3. For between 4 to 9 would be 5. 16 minus 9 would be 7. Here, do you see any pattern? So from here it would be 1, then 3, then 5, then 7. There would be an interval of 2. So this proves that square roots are these. It's just some logic we could talk about. Then 25 minus 16 would be 9. 36 minus 25 would be 11. As you see, as it goes longer, there's still an interval of 2. When it comes to cube roots, this interval that we are analyzing for now won't be possible. Let's continue. 49 minus 36 would be 13. 64 minus 49 would be 15. There, we have succeeded. Before we proceed to answering this, let's have number 9. 9 raised to 2 would be 81, since 9 times 9 is equal to 81. There's also some logic in 9 raised to 2. It could also be 3 times 3 times 3 times 3, since these 4 factors all represent 2 cubes, which are 9 and 9. Then 9 times 9 is equal to 81. Just some pure logic. Therefore, now that we have square roots 1 and 9, we could now solve this. As long as you memorize these, we are able to answer perfect squares in radical expressions. For 81, it would be 9 raised to 2. Then 9. Basically, radical expressions are the reverse of square roots. Not only those, but also cube roots and any other roots. It could be either raised to 4, raised to 5, raised to 6, or in other words, you could just say degrees. As the index goes higher. they are still represented as radical expressions. Let's make some examples. Without looking at these, if you want to pause the video, memorize all these, feel free to do so. Number 10, 10 raised to 2, be 100. I'll leave this as a clue. Do you know that this radical sign is also equal to this? Every radical sign that has no index already is understood as this, square root. Square root of 3, still like this.